Hello, friends. Welcome to the Programming Hub. So, this is session 2 on prime number related program. So, the prerequisite is you have to come across session 1, then only you will be able to understand the this program, what we are going to discuss now. So, first, if you already gone through first video, then it is fine. So, today, what we are going to, today our agenda is we are going to discuss about a program, and the program is, so we will be having one number and we have to return the smallest prime factor of all the number. Okay, so this is the main thing we are going to talk. So this is the thing we are going to talk. What do you mean by smallest factor? So that is the thing. Let's say, as for example, n is 10. So we have to start from 2 to n. Okay, so let's say 2, 3, 4, 5, 6, 7, 8, 9, 10. So we already know from the previous class what is the factor. If any number is perfectly divisible by any number, that number will be called a factor. Now we are looking only for the prime factor, and that also must be a smallest one. Okay, so for 2, the smallest prime factor will be what? For 2, smallest prime factor will be what? 2. For 3, smallest prime factor will be 3, because it is not going to divide by the 2. So automatically 3 will be divisible. So this will be smallest. So 2 is a prime number and 4 is divisible by 2, meaning that 2 will be the smallest prime factor for 4. 5. 5 is not going to divide by 2 or 3. So 5 itself will be the smallest prime factor for 5. Same way, for 6, 2 will be the prime factor. For 7, 7 will be the smallest. For 8, 2 will be the smallest. For 9, 3 will be the smallest. For 10, what will be the smallest? 2 will be the smallest. So this will be our answer. So let's say n is 10, meaning that you have to find for each and every number which is coming between the range from 2 to n, all the smallest prime factor. Let me take another example for making you more clear. Let's say I'm talking about 20. So 2 to 10, 2 to 10 we have already seen. So that same value we can pitch in here. Okay. Next will be next number will be 11. Next number will be 12. Next number will be 13. Next number will be 14, 15, 16, 17, 18, 19 and 20. So for 11, smallest prime factor will be what? 11. For 12, 2 will be the smallest. For 13, 13. For 14, 2. For 15, 3. For 16, 2. For 17, 17 is not going to divisible by anything. So 17 itself will be the smallest prime factor for what? 17. For 18, 2. For 19, 19 itself, and 20 it will be 2. So for next thing, this and this plus will be the answer for if n is 20. So this is all about what we have to discuss. So if you want to find this, so I have made one calculation here. Okay, so this is very similar program which is this is very similar program which is yesterday we have discussed. You have to return all the prime between n to 2 to n. Same kind of program, same kind of algorithm we are going to follow here also. So what was the algorithm? Do you remember? So we had discussed yesterday one algorithm that is called sieve prime. So where we were taking what means for previous program we had scenario like we have to print all the prime number from 2 to n. So for that what we have done, just I am recollecting the information and from there I will try to make the logic. Okay, so we had taken one boolean array of size what n plus 1. So new int, sorry, I'm sorry, so boolean means it should be boolean only of n plus 1, and then we have started with all true value here, and then we have started our loop from 2 to n, and not n is especially we started from 2 to square root of n, and whenever we are finding the prime number and whatever the number is perfectly multiplier of 2, then we were marking as a false because that cannot be prime. Same kind of logic we are going to talk here. Okay, let's see what we are going to do. So here also for finding the logic, what we are going to do, we are going to take one array. So int, and we can keep that SPF. SPF means smallest prime factor, and then we can write new int, and what should be the size n plus whatever. Let's say here in this example I have taken 50 value. Okay, so let me first make this. So 48, 49 and 50. I have taken big scenario because I want to, so the explanation will be very nice here. So what we can say, this time I have taken n equals to 50. So what should be the size of SPF? 50. In last program itself we have seen why we are taking n plus 1. So I always start from 0 to n minus 1, and I need to calculate 50. If you are going to take n, then we can calculate only 0 to 49. Okay, so that's why I have taken n plus 1. So n plus 1 will keep the value from 0 to 50. So first value will be what? 0, and 0 and 1 we are not going to consider at all. Okay, second thing what we are going to do here as per the logic, I will think like whatever the value in, so currently in SPF everything will be 0. So what I will be taking as a means let's suppose we can say, suppose if all the index value in SPF is the smallest prime factor. So for 2 is a smallest factor, prime factor. 3 for 4 is the smallest factor. 5 is the smallest factor for 5. 6 is the smallest factor for 6. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 30, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49 and 50. So just I am considering whatever the I value for SPF index value is a prime factor for that particular number. So I'm thinking like 2 will be the smallest prime factor for 2, 3 will be the smallest prime factor for 3, 4 is the smallest prime factor for 4, 5 is a smallest prime factor for 5, and so on. 50 is a smallest prime factor for 50. Okay, this is just my consideration. I'm supposing it as of now. Okay, and then what we have done last time also, we have created one boolean array, and in boolean array I kept everything is a true. I was considering every number is a prime number. Same way here also I am thinking every index value is a smallest prime factor for that particular value. So same way 17 is a prime factor for 17 as of now. Okay. Now what we have to do? We are going to check each and every number now. Each and every number. If that number is prime, then all the multiple of that particular number for that number smallest prime factor will be that value only. Okay, what I am trying to say here, let's say I have started 2, and what I have to check, if this value and this value is same, meaning that that is the smallest prime factor actually. Okay, so so what I'm trying to say here, if SPF of I equals to I, meaning that that is a prime number and that is the prime factor, means this I is a prime factor, smallest prime factor the for this 2 actually. Now from here, if we got this, if we got this value, what we are going to do, we are going to check all the multiple of 2, and for the multiple of 2 what will happen, that 2 will be the prime factor, smallest prime factor. Okay, so for 2, 4 will be the for 4, 2 will be the prime factor, smallest prime factor. For 6, 2 will be the smallest prime factor. Okay, so what we are trying to do here, I will 20, 18, 16, 14, 12, 22, 24, 26, 28, 30, 40, 50, 80, 38, 36, 46, 44, 34, 32, and okay. So for this 4, 2 will be the smallest prime factor. Let me write with some different pen so that we should be the that will be helpful. 2 for 6 also 2 will be smallest prime factor. For 8 also, for 10, 12, 14, 18. Okay, okay, okay. So this for this many number we have found the smallest prime factor. Okay. So after that, what we are going to do? We are going to go for next number, and we are seeing what we had the condition, if SPF of I equals to I, meaning that this 3 equals to 3, meaning that this is a prime number, and for that value we have to check whatever the multiple of that value, and for that value everything will be prime actually. Sorry, everything will be means smallest prime factor. So multiple of 3 is 6, multiple of 3 is 9, multiple of 3 is 12. Okay, so let me go now. First multiple of 3 is 6, and 6 we can see it is already marked, means that we are not going to change. Okay, for 9 we have to mark, then 12 it is already marked, and for 15 we have to mark, for 18 it is already marked, so we are not going to touch 18. 21, then 24 is already been marked, so we are not going to touch that also. 27, 30 is already marked. We already found the smallest prime factor for 30, so we are not going to check that. And 33, then 36 is already marked. 38, no, 30, not 38. 39 is divided by 3, so it means that we have to mark this. And then 42 is also divisible by 3, but it is already marked, so we are not going to do anything. 45 and then 49. 49? No, I don't think so. 49 will be divisible by 3. Okay, so it should be 49 itself for now. Okay, so let me mark other number. So smallest factor for 9 is 3. Smallest factor for 15 is 3. Smallest factor for 31 is 3. 3 and then 3, then 3 and then 3. I think I have marked everything. Okay. Okay. So now we have to go for next value. Next value is not SPF of I equals to I. 4 equals to 2, meaning that it is not a prime. So we are not going to check. We are going to skip this one. Okay. Next value. So for 5 is means 5 equals to 5, meaning that this is correct and this is a prime. Now we have to find the prime factor for this. Okay. So what and all will be divisible by 5? 10 will be divisible, but 10 is already marked, so we are not going to change this. Then 15 is already marked, 20 is also already marked, then 25 is also marked, 30 is also marked, 31, no, 31 is anyway not divided. 35 is not been marked and it is divisible by 5, so we have to update this value. And then 40 is already marked, 45 is also marked, and 50 is also marked. So only one value we have to update, and that is for what? 35. So this will be the 5 will be the smallest prime factor for 35. Okay. Okay. So next will be 6. 6 we are not going to check. Why? Because this is not satisfying this condition. For 7, okay, we are going to check the 7 now. 7 meaning that we are going to check all the multiple of 7. If it is not been marked, how we are going to do for this, how we are going to check whether it is not been marked, we will check later. That first we are going to trying to find all the multiples of 7 which is not marked yet. Okay, so let me see that multiple of 7 is, first is 14 which is marked already. Second one is 21, it is already marked. And 7 3 is 21, 7 4 that 28, it is already marked. Then 7 5 that 35, it is already marked. 7 6 that 42, it is also already marked. And this is the value we have to update. Okay, so we are going to update this value with 7. And you know one thing, we always run our loop I should be I into I should be less than 50. So we were where 7, so 7 into 7 less than 50 is condition correct. Okay, now as per the loop we are going to do here, and if we do this one, so 8 into 8 is less than 50 is not going to correct condition. Okay, this is not a correct, so our loop will end here. And now if you will see it, this SPF array, SPF array is what? This one is SPF array. All this colored value what you are seeing, that is your SPF array. If you will see this SPF array, you will find your output. Okay, let me see that whether we got or not. So let me write this time with black. Okay, so we have the value as the answer we are writing here 2 3 5. I'm sorry for that, I think we have to write all the value, right? So our answer is 2 3 2 5 2 7 2, 3, 2, 11, 2, 13, 2, 3, 2, 17, and so on. Last what we have 2, 7, 2. Okay, so this will be your answer. Okay, any problem? I don't think so. If you have, you repeat this one, you will get it. So what we have done as a summarize observation, if we are going to write in same, let me take another page. So observation is, or we can say, what is the step? That is a better thing. So what we have created, first one, we have created SPF array with index value. This is the first thing. Second step, we started loop from 2 to square root of n. Okay, what is this n? Square root of n. 2 to square root of n. Okay, and we were checking if SPF of I equals to I, then we are going to do some logic. So basically we have done this. So let me write the pseudocode, then you will get clear. So it's time to write the pseudocode. So we have to return, right? And we have to return the entire array. And let's say I'm writing method name is smallest prime factor. So I will be given with one value, that is n. Now first things what we have to do, we need one array. So int SPF equals to new int, what will be, should be the size, n plus 1. Now we have to fill this array, fill this array with index value. Okay, let me fill it. For int I equals to 0, I should be less than n plus 1 and I plus plus. Okay, what simply I have to do, SPF of I equals to I. So first step is done. Now what I have to do, I have to start a loop till square root of n. So this is our main logic we are going to write. Logic to find the SPF. Okay, so let me start writing. So what I am going to do, for int I equals to 2. We are going to ignore the array of SPF of 0 and SPF of 1. So I have started from 2. Till where I have to go? I into I. I'm sorry for that. Okay. I into I less than equals to n and I plus plus. Okay, this is also done. Now what I have to do, first I have to check that value is prime or not. How we are going to check that? If SPF of I equals to, not 2, it should be I. Okay, then what we are going to do, we are going to update our entire array. How we are going to do, let me start another loop with j equals to, in last class itself, you know from where we used to start, I into I, and j should go till less than n plus 1 and j equals to j plus I. This is from previous class only, and you can see, you can make the logic by seeing the assumption also. That is not a problem. Okay, now one condition you have seen here, we have to update the value only when it is not updated before. Okay, how you will check that? So let's say you are here, okay, and you have to update this one. So if this 4 is also, this 4 and this 4 is matching, meaning that this is not updated before. Like that, 3 and 3 is matching, meaning that it is not updated before. 5 and 5 is matching, means it is not updated before. So how we are going to check that here? Okay, let me check that. If SPF of J, so let's say you are coming with 2, meaning that I into I, what? 4. So 4, SPF of 4 not equals to J. If not equals, meaning that it is already updated, so we should not touch. So what we should do, we should make different condition, opposite condition. So we should go for equals to condition. If it is already, if it is equals, it means that it is never been updated. So what we should do for this one, SPF of J must apply with what we are coming with, I. So it should be okay, and then close the for, and then close the another if, and close the main for. You understand this logic what I have done here? Meaning that, so let's see here. Let's say I have I have taken 2 4, not 2 4, yeah, 2 3 4 5 6, and for this, if it is 2 3 4 5 6, this was the thing, right? So first time it is coming with 2, so this is correct, and this is, so our pointer is here, meaning that I is what? 2. And now, so J equals to I into I, meaning that J is here, okay, and J is less than n minus 1, correct? Means 4 is less than equals to 50, then this is correct. So what is condition here? SPF of J, meaning that SPF of J equals to J, meaning that 4 equals to, it is J, so it is 4, means condition is true, meaning it is never been updated till now. So what I should update here, this 2 value I should update here. And where is this 2? This is in I. So what I have written inside, SPF of J, SPF of 4 equals to 2, meaning that this is updated to 2. Okay, same way what will happen? Now it will go J plus I. What is J? 4. What is I? 6, meaning that now your J will go here. And what will be the condition? 6 equals to 6, meaning that SPF of 6 equals to 2. So this value will be changed to 2. Okay, when it is let's say 8 or something, so next time if it is already been updated, this condition itself will be wrong and it is not going to update. And same thing we have also discussed here, when the value is already updated. So uh, you can see 12 was the candidate which can be updated by again 3, but it is not getting updated. Why? Because we are checking the condition. What we are going to check the condition here, this is the main condition here. We are going to check if it both are equals, then only we are going to update, otherwise we are not going to update. Okay, so this is rough. I am going to delete this. Okay, so at last what we should do, tell me. So almost we have completed the code. So every value is available where every value is update available in SPF array. Return SPF. Okay, so let me see my all codes are fine or not, curly braces and all. So let me correct with this. So this is closed here, this is closed here, this is closed here, and this is closed here. Okay, and then this is closed here, and at last this is closed here as well. And now at last what we are going to do, close the bracket. Any problem till now? Because we are going to talk about the time complexity. So anyone can say like what should be the time complexity? Okay, let me say that. I use this color this time. This is how much? O of n time n plus 1 basically, but in terms of big O notation we can say O of n, and how much this is taking, this part. This is the main part actually. This part is taking, you remember yesterday, what was that? O of n log of log n. So this was the total time complexity. Okay, this is your TC. If you are going to talk about SC, what will be the SC? Space complexity O of 1. How I am saying that? How I am saying this will be O of 1 space complexity. See, here also we have taken one array. Okay, but this array is means this program itself is telling me return me the array. See here, the program itself is telling return me the smallest prime factor for all the number. If this would have been told like you have to print, so for printing, for my purpose I have initialized one array, but now this is what it is telling me, you return me, means that guy already told me you give me the array. Give me the array means this is already given, so I have not created for my purpose, it is created for the output, actually output purpose. If it is created by the for the output purpose, so we are going to consider as not created by me for my purpose. It is created for the generating output. This is simple example. If you say, if you are going to buy something from the shop, and let's say you are going to buy rice, okay, and that guy is not going to give you any plastic because plastic is banned. So what you are going to go with? You are going to go with container, and container is what? Yours container. It means that that shopkeeper is not giving anything extra for his space things and all. So you have your own thing, and you have carried all the rice inside that container, and you came with that. Means that that guy is not giving you anything. Okay. So but and same kind of things also applicable here. I have been told you have to return me the SPF array. So for their purpose only I have created the SPF. If in program it is written like you have to display means he is not telling me to create, he is not asking anything. So for displaying I have to create the SPF. So in printing case, if it is being told like you have to print the array, print array, okay, print the smallest prime factor. In this case, what should be the space complexity? SC of n, because you have taken one. I think I'm not in hurry. Why I'm making the mistake? No problem. Sometimes happens as C equals to O of N in terms of big O. So this time my program is not telling. I have created for myself. So for printing the smallest prime factor, the space complexity will be O of N. Okay. So this is all about this program. I don't think so you will have any confusion. If you have any confusion, you can write into the comment box. I will be solving it out, whatever the confusion. So this was our agenda to discuss about this program. In next session or next video on the prime number, I will be talking with I will be coming with another program. Thank you for watching. If you like this video, please like, subscribe and share. And for getting the notification, please press the bell icon. Thank you.